Hello students, welcome back to my channel. In today's session, we will be understanding the concept behind the merge sort. So let us go ahead and see what is a merge sort mean. So before we go ahead and see it, first of all, we need to understand that merge sort uses a technique called as divide and conquer methodology. Now, what is this divide and conquer? As the name says, so divide means at any point of time, a given problem is divided into smaller problems so that we can easily find the solution for a smaller problem. So once we have that smaller problem, we are going to merge those and then get the solution for the bigger problem. Okay. So how it is applied in a merge sort is, as you can see that here we have an array with 7 elements. It is divided into 2 array based on the midpoint. So if I am considering this as a midpoint, it is divided into 2 array. Now I am supposed to sort these 2 arrays. Now further what I'm going to do is I'm going to find a midpoint and divide this into further 2 arrays. Similarly, this is also divided into 2 arrays until I'm going to find a single element. As you can see, single elements in a particular array we have received. So when I find a single element in any array, I say that by default this is sorted. So if I'm considering this example, there is only 38, it is already sorted. Similarly, 27, it is sorted. So each one of them are sorted in their own arrays. Now our task is combine them back in a way that they are sorted. So what I'm going to do is first I will take these two. So while joining, I will use the method of two-way merge, which we learned in the last session. You can go back and check the video. I'm going to use that methodology and then I'm going to merge them into an array such that this resultant array is sorted. Similarly, other two arrays are also added. Wherever there is a single pair is not available, I'm going to keep it as it is. Now further, as you can see, this is a sorted array, this is a sorted array. I'm going to combine them, merge them together and form another single array. Now when I'm combining here also, as you can see, I will first check which is the smallest element and I'll place it in the first position. Next, I will check the smallest element, next element and next element. So this is already sorted. Similarly, this is also already sorted. Now the final task is I need to combine these two. I will use the once again two-way merge technique. Okay. And then finally, I'm going to get my array sorted. So this is how we are going to use the merge sort technique. So we have an algorithm in order to divide the array, and then in order to combine that also we have a separate algorithm. So when we combine these two, it will become nothing but our merge sort. So in this session, I will only discuss the concept behind it. In the next session, we will see a in detail iteration or with an example. All right. Okay, let us quickly see the algorithm. How does it look like? So let me take one simple example, 8, 23 and 1. Suppose this is the array I want to sort. So what I need to do is I need to first find the midpoint, like as I have seen. So initially I will take something called as so array stands for the name of the array and L stands for the lower bound. So if it is 0, 1, 2, so L will be lower bound and H will be the higher bound. All right. So now when I want to perform a merge sort, what all things I need to do is first is I am going to divide this until I have a single element and then I'm going to merge it. So in order to do that, first I will find the midpoint. So mid is going to be left plus high value, lower value plus high value divided by 2 will give me the mid value. So once I have that, what I'm going to do is I'm going to recursively call the merge sort. Why this is because like we have seen in the previous example, let us see it once again. What I'm doing is I am taking an array, finding the midpoint and then dividing it irrespective of how many number of elements are there. Same thing I'm doing. I'm taking a L value, I'm taking a H value, finding a midpoint and then dividing it. So this is a recursive procedure. I need not again and again repeat the code. Hence what I'm going to do is I'm going to simply repeat it. So that is called as a recursion. So I'm going to use that code. So in order to do that, I will call the merge sort. So merge sort, first I need to find the merge sort of this and then I need to find the merge sort of this. That's why what I'm going to do is I will pass the array which has a lower bound as L and which has an upper bound as a mid, because this is my new array for which again I want to find out the merge sort, as in I want to divide it further. So L becomes the lower bound and M becomes the upper bound. Similarly, now I need to find out for this. So here merge sort of array M plus 1, because M is up till here, this is nothing but M plus 1. M plus 1 becomes the lower bound and H becomes the upper bound. So similarly, I'm going to use this technique for all. All right. Now, until when I am supposed to do this? Until when? So I have a condition that only when my lower bound is less than upper bound only I can do. That is only until I have a single element, I'm going to go on performing the merge sort. So once I complete all the merge sort, as in until I get all the elements, which single elements. Once the moment I get a single element, I am supposed to start merging them. So in order to merge that, I will call the lower bound, I will call the middle value, and then I will call the upper bound. Okay, so this is how I'm going to do. So this is nothing but our divide part of the algorithm, and this is nothing but the conquer part, or nothing but a merge part of the algorithm. I hope this is clear. So when we do an example in the next session, it will be all the more clear. So as of now, this is the logic behind it. Now let us go ahead and see how does a merge work. So remember, this merge will be called only when we end up having a single elements. Only when the entire array is divided. That is why it is within the bracket. We are recursively going to divide the array into the single element. The moment we have a single element, we are going to start calling the merge operation. All right. Now let us see the code for merge. So as you can see, suppose I have 8, 23 and 1. Now I need to combine them. Let us take these two. Obviously, initially I am going to combine these two. So I am going to say that, now remember, whenever I have called this function, I would have called it merge sort of lower bound, which is, since this is 0, array 0, and midpoint would have been 0 plus 1 divided by 2, which is once again 0. Okay, so here this is the lower bound and this is the mid. And similarly here merge sort array, here we would have called mid plus 1 is nothing but 1 and high is also 1. Okay, now I am going to take the I value as L, and what is the value of L, which is 0. I am going to take the J value as mid plus 1, which is nothing but 1. So obviously I is here and J is pointing here. Now I am going to check while I is less than or equal to mid. Yes, I is less than or equal to is valid. Similarly, J is less than or equal to H, else it is true. I'm going to compare the value of A of I and A of J. Now, why am I doing that? I want to take only the smallest value. When I'm comparing, I'm finding that A of I is smaller. So whenever A of I is smaller, then I'm going to store it in another temporary array called as C. So here 8 will be stored. The moment I store this, I'm going to simply increment my I value to next value. Okay, similarly, K value will be moved to the next value because I want to store the next value here. And then once again, I'm going to check if A of I, I'm going to check the while loop while I is less than or equal to mid. Since mid value is 0 and I value is 1, this particular condition is not satisfied. Hence, we are going to come out of the while loop. All right. So now if you remember, we have taken one of the value into the temporary array, but there is a remaining value. Now, in order to copy this remaining value, we have another code, that is this code. This is to copy the remaining code. So what I'm going to do, I'm going to check while I is less than or equal to mid. That is, this is to check whether still there are elements left. So this is not true in this case because mid is 0 and I is greater than mid. Hence, we know that there are no elements present in this particular array. Next, I'm going to check the another array where I'm checking while J is less than or equal to H. Yes, J is still here and it is equal to H. Hence, in that case, what I'm going to do is C of K is equal to A of J. I'm going to copy 23 here and then j is equal to j plus 1, increase the value of j, and k is equal to k plus 1. I'll simply increase the value of k to the next one. All right. So once again, this iteration will happen. I'm going to once again check while j is less than or equal to h. But in this case now j is greater than h. H value is 1, but j has become greater than h, which means that there are no elements left. Hence, this is done. Hence, this step is completed. All right. So this is how we are going to combine. So as you can see, these two combination is done. I hope this is clear. So in the next session, when we are going to see the detailed example, we will be discussing. So that time I hope it will be clear. So where we will take a bigger example and we will iterate, dry run the entire code one by one. All right. So before going, let us quickly see the complexity, time complexity. As you can see, as the time increase, as the number of values, the n value, number of elements in the array increases, the time also increases. So that is why the best case, worst case, and the average case of merge sort is always order of n log n. This you need to remember. And this is the graph it looks like. All right. So that's all in today's session, students. I hope it is helping. In the next session, we will discuss the example. Thank you for watching. Keep learning.